Hello everyone and welcome to the video on geometric sequences and series. Our skill objectives for this particular video are 1. Recognize a geometric sequence. Number 2. Find the general term of a geometric sequence. 3. Evaluate geometric series, finite geometric series, and evaluate infinite geometric series if possible. It is possible to do it, so we'll talk about that as well. And then we're going to use geometric sequences or series to model problems. Our conceptual objectives. Number 1, we want to understand the difference between geometric sequences and series. And 2, distinguish between geometric and arithmetic sequences. And 3, understand why it is not possible to evaluate all infinite geometric series. Let's start with a definition. A sequence is said to be geometric if each term is found by multiplying the previous term by a number r. That number r is called the common ratio. So in other words, if I look at this in terms of a recursive formula, I know that when I want to find, if I know a term, if I multiply it by r, I will get the next term in the sequence. Now a consequence of this is also that the ratio of consecutive terms will always be the same. So if I take a sub 2, the second term divided by the first term, that's going to give me the same thing as if I took the third term divided by the second, the fourth term divided by the third, and so forth. That will always equal the number r. Let's take a look at a couple examples. In the first example, my sequence is 5, 25, 125, and 625. Well, what I notice on this one, if I go in through and take 25, the second term divided by the first, that's equal to 5. If I take 125, divided by the second term, the third term divided by the second, that is also equal to 5. And if I take the fourth term divided by the third term, if I go through and do that, that also is equal to 5. So in this case, that first example, that is a geometric sequence, and r is 5. My common ratio in this case is 5. In the second one, we go through same process on that. I'm going to take the second term, negative 4, divided by 8. That does give me a negative 1/2. If I take 2 divided by negative 4, that will also be negative 1/2. And if I take the negative 1 divided by 2, that also equals negative 1/2. And so, when I go through and divide consecutive terms like this, I get the same value. In this case, r is equal to negative 1/2. Now, what I'd like you to do, I'd like you to pause the video. I'd like you to go and check number 3, determine if that is geometric or not. Go through, take the ratio of consecutive terms, and if it is geometric, tell me, identify what r is. So pause the video and check it, and when you're ready, come on back. Welcome back. You should have found that this was actually, number 3 is a geometric series. Let's go through and move this up a little bit. We'll take a look here. If we go through on this, and I take the ratio of consecutive terms, well, the first one I would do is, again, remember, it's the second term divided by the first. That is going to be 1/6 divided by 1/4, which comes out to be, remember, dividing by 1/4 is the same as multiplying by 4, so it gives you 4/6. That is equal to, which would be 2/3. If I do the same thing with 1/9 divided by 1/6, 1/9 divided by 1/6, that will equal 6/9, which also equals 2/3. And so in this case, you can check other ones. If I take 2/3 times 1/9, I do get 2/27. I get that this is a geometric series, and r is equal to 2/3. Now let's take a look and develop the formula for the general term. We know how to do the recursive formula. We just define the first term, and then it's going to be a sub n plus 1 equals the first term, or a sub n times r. But in this case, what we want to do is we want to develop that general term. So I'm going to use that whole definition, how we do that, to go through and see if I can come up with a pattern. Well, in this case, what I know is I have my first term, a sub 1. I know to get the second term, I have to take my first term here and multiply it by r. So I get a sub 1 times r, or I could think of that as r to the first power. A sub 3 is going to be a sub 2 times r, the previous term times r, which since a sub 2 is a sub 1 times r, that comes out to be a sub 1 times r squared. A sub 4 is going to be a sub 3 times r, which would become a sub 1 times r cubed. A sub 5 is a sub 4 times r, which comes out to be a sub 1 times r to the fourth. And so, looking at that, we can kind of see a pattern here. You'll notice, some of the things you might notice is that my subscript number here is 1 less than the power that we have on r. That's even true up in the first one, because I can look at that as a sub 1 times r to the 0 power, because r to the 0 would be 1. So in this case, what we get is that the general term, a sub n, is going to be the first term, a sub 1, times r to the n minus 1 power. So this is going to be the formula, the form for the general term. Let's see how this works. In the first sequence that we had before, we want to find that general term. And I know that in that first sequence, a sub 1 is 5. And I also knew that r was equal to 5. And so I could say that a sub n is equal to 5 times 5 to the n minus 1 power. Now, this is one that they will sometimes go and simplify. They could go and say, well, since this is, we can think of that as 5 to the first, they will often go through, and since the bases are the same, they'll add the exponents and they'll write that as 5 to the n. Now, I'll tell you, on a test or quiz, I would take either one of these. But please keep in mind, in this situation here, you can simplify that. In the next sequence, I have my first term is 8. We knew r was negative 1/2, and so a sub n would be 8 times negative 1/2 to the n minus 1 power. In the third one, my first term is 1/4, and we found that r was equal to 2/3. So a sub n is going to be 1/4 times 2/3 to the n minus 1 power. Now let's take a look at the geometric series. In this case, what's happening here, I have my partial sum, the sum of my first n terms of that geometric series, is going to be the sum as I goes from 1 to n of a sub I times r to the I minus 1 power. Now what happens on this? So this means that this series, because I'm going to go up to n, is going to be s sub n is going to be a sub 1 plus a sub 1 times r plus a sub 1 times r squared plus a sub 1 times r cubed. And this pattern continues all the way up to a sub 1 times r to the n minus 2, and then a sub 1 r to the n minus 1. Remember, this right here, that right there, would be the nth term. Now, one thing I can do with this, I can also go through, and to develop the formula that we're going to use, we want to go through and multiply. I'm going to multiply my previous s sub n. I'm going to multiply that by r. So I'm taking everything up here, and I'm multiplying it by r. So when I take a sub 1 times r, I get this. And then a sub 1 times r here times another r, I get a sub 1 r squared, and this will continue on. So you'll notice that this term right there, when I multiply it by r, is going to give me a sub 1 times r to the n minus 1. And here I'm going to get a sub 1 times r to the n minus 1 will give me, times r will give me a sub 1 times r to the n. And now what I'm going to do on this is I'm going to subtract these two. I'm going to take that first sequence, and I'm going, this s sub n, and I'm going to subtract the r times s sub n. So what's going to happen here is I'm going to be subtracting all of this from here. Well, in that case, when I do this, a sub 1 times r, when I combine the like terms, a sub 1 times r minus the a sub 1 times r, these will drop off. And this will drop off. And these things will just continue to drop off. This will be canceled out over here. That will drop off. And what I'm going to be left with is that when I subtract these two, that's going to be s sub n minus r times s sub n. And what I'm going to be left with over here when I subtract all of this and simplify it, I'm just going to have this first one here, a sub 1, and it's going to be minus, because I'm subtracting, so it's going to be minus that one. So I have a sub 1 minus a sub 1 r to the n. Now at this point, what I need to do is factor this. You'll notice that I do have a common factor in each case. I can pull out the s sub n, and I'll be left with 1 minus r here. And when I pull out the a sub 1, I'll be left with 1 minus r to the n. Now solving for s sub n, that partial sum of this geometric series is going to be a sub 1 times 1 minus r to the n all over 1 minus r. And this is the formula that we can use to find the partial sum, the nth partial sum of a geometric series. So now let's see how this one actually works through. Okay, we're going to start out in this case with this first series, n equals 1 to 6 of 3 times 2 to the n minus 1. And so what I'm going to do on this, I know when I put in 1, I'm going to get 3 times 2 to the 0, so I'm going to get 3 plus, when n is 2, I'm going to get 6. When n is 3, I'm going to get 12. When n is 4, I'll get 24. When n is 5, I'll get 48. And when n is 6, I'm going to get 96. Now that would be the sum. Now what happens on this one, at this point this is a smaller sequence, you could actually add this up and see that it works out, do that sum. But we can also use the formula. And you'll notice on here, I wrote this out, and what I have is that a sub 1 is equal to 3, and I know r is equal to 2. So I know the sum, this is s sub 6, there's 6 terms, so s sub 6 is going to be 3 times 1 minus 2 to the 6th power all over 1 minus 2. At this point, I can put this into my calculator. And what I come up with when I do that is that this comes out to be 189. So what you should do right now is pause the video and add up those 6 values and also do this on your calculator and make sure that you do get the exact same answer. One of the problems that you do have to be aware of, remember to put the parentheses around the things in the what you have in the numerator and in the denominator. So if you enter it in exactly as I have it written there, it should work out. So pause the video, double check those. If you were not able to get it to match, please make a note of that in your, and be sure to ask about that when I come around to check your notes. But let's move on to the second one here. Now this one is a little bit different because the way it's set up, it could cause a problem. You'll notice in this case that we're starting with n equals 0 in this case. We have n equals 0, and we're going from 0 to 5. And so what happens on this, when I write this out, when n is 0, I'll get 5 times 1/2 to the 0, which will equal 5, plus, when I multiply by 5, now when I put 1 in for n, I will get 5 over 2, plus 5 over, when n is 2, I'll get 5 over 4. When n is 3, I'll get 5 over 8. When n is 4, I'll get 5 over 16. When n is 5, I will get 5 over 32. Now, the reason I wanted to show you this one here is because in this case, this particular sum that we have here is actually the sum of the first 6 terms of a geometric series. In this case, the 5 is in the a sub 1 spot, and we know r is equal to 1/2. And so s sub 6, this right here is s sub 6, is going to be 5 times 1 minus 1/2 to the 6th power all over 1 minus 1/2. And again, I can now go through, put this into the calculator. Pause the video. Why don't you put this in the calculator, see what you come up with. Remember also to put the parentheses around that denominator. See what you come up with, and when you come back, we'll see how our answers match up. Welcome back. You should have got in your calculator. You should have come up with 9.84375. As a fraction, that is equal to 315 divided by 32. So that's what you should have come up with on this one for this particular series. Now, again, please note, I want you to be aware of how this thing was different. Again, this one started with n equals 0. So in this case, when I go from n equals 0 to n equals 5, that is going to be 6 terms. Where if I go from n equals 1 to n equals 6, I have 6 terms. If necessary, as you go through this, make sure to, it might help to write these things out, because I just did 2 different limits, but we could, we could start this series with n equal to whatever value we want and go to whatever value after that we want. So that could make a difference in terms of how this series works out. Now let's take a look at an infinite geometric series. And to do that, to come up with a formula for that, really what we're going to look at, we're going to start out by looking at this particular series right here. Okay, that sum. And what happens on this one, we want to think about different values of r. What happens when we put different number values in for r. For example, if I let r equal 2, and I take higher and higher powers of 2, that is just going to get larger and larger and larger. Okay? But if I let r equal something small, something close to 0, like 1/2, if I take higher powers of 1/2, I get things that are smaller. I will continue to get values close to 0. So if I'm looking at the sum as I equals 1 to infinity of a sub 1 times r to the n minus 1, if r is something that is small, like if the absolute value of r is less than 1, so any value between -1 and 1, then what happens here, I know that this r to the n is going to end up getting very, very small, going to go to 0. So the sum in this case is going to be a sub 1 times 1 minus this small number raised to the infinity power is going to go to 0 all over 1 minus r, or so I'll get a sub 1 over 1 minus r. So I can say 2 ways of writing this that I've seen. S is the sum, the infinite sum of a series that is a sub 1 over 1 minus r, or I've also seen it written as S sub infinity equals a sub 1 over 1 minus r. I think in our book they actually just use this notation here, that they don't necessarily use either of these. But I have seen these, and for those of you who are going into the IB math class next year, you're going to want to be familiar with both of these as well. Now the key on these, in order to do that infinite sum, is that r, the absolute value of r, has to be between has to be less than 1. And so when I look at this first problem here, I want to find this sum if it's possible. The first thing I'll notice on here is that when I go from 81 to 9 plus 1 plus 1/9, I know r is equal to 1/9. And so I know the sum of that series is going to be my first term, which is 81, divided by 1 minus 1/9, which is 81 divided by 8 over 9, which equals 81 times the reciprocal of that, which would be 9 over 8, which when I multiply that out, that's going to be 729 over 8. So that would be the sum of that infinite series. In the next one, you'll notice on that one, we're going through, we start out with 1/4, I go to negative 1/12, positive 1 over 36, negative 108, and so forth. And if you look at that, you should notice that r comes out to equal, in this one, r is equal to negative 1/3. And so my sum in this case, s, is going to be 1/4, that first term, divided by 1 minus a negative 1/3, which will be 1 over 4, divided by 1 plus 1/3, which will be 4 over 3 when I get the common denominator, which comes out to be 1/4 times 3 over 4, which will result in 3 over 16. So there will be the sum of that infinite series. What I'd like you to do is pause the video, and I would like you now to find the sum of this particular series, the last one, number 3, where n goes from 0 to infinity of negative 8 times negative 1/2 to the n. So pause the video, and once you're done, once you find that sum, come back, we'll take a look at what you came up with. Welcome back. In this one, you should have found that the sum came out to be negative 16 over 3, or negative 5.333 repetant. Now let's see how that one worked out. Now in this case, again, you have to be aware of what's happening on this one. N is 0 is where we start out. And so that particular series, it's going to start out, when we put 0 in for n, you're going to get negative 8. When I put 1 in for n, I'm going to get plus 4. When I put 2 in for n, I'm going to get negative 2. And then when I put 3 in for n, I'll get plus 1. And it's going to just continue on like that. So you have, in this case, that first term is negative 8. And so that sum is going to be negative 8 divided by, in this case, it's very easy to see what r is. It's negative 1/2. 1 minus a negative 1/2, which is negative 8 divided by 3 over 2, which is negative 8 times 2 over 3, which equals negative 16 over 3. So that would be the sum of that particular series. Now let's look at an application problem. Okay, in this case, we have a new graduate that decides she wants to save for a house and is able to put $300 every month into an account that earns 5% compounded monthly. And we want to know how much will she have in the account after 5 years. Well, first of all, let's recall the compound interest when it's compounded monthly. In this case, we have P, in this case, R is 5%. It is going to be compounded monthly, and so T is all, so what happens is it's 0.05. So we have P times 1 plus 0.05 over 12 times to the 12t power. Now, one of the things that they do on this one, because what we're doing is every month we're putting things in. So I'm going to let t equal n over 12, because that will be the fractional portion. If it's the 5th month, it's 5 over 12. If it's the 10th month, it's going to be 10 over 12. So we're going to let t equal, we're going to change this from t, using t, which is years, into using months. And to do that, we're going to let t equal n divided by 12, where n is the number of months since the investment. So now this thing becomes, when I put n over 12 here, that will just simplify to be n. And I have a sub n, the amount that, for whatever month I have, is p times 1 plus 0.05 divided by 12 to the n power. Now in this case, p is $300. So I'm going to put 300 times, now when I put this into the calculator, it comes up with this decimal. and it's raised to the n power. And what you should recognize here is that this is a geometric series. Now, if I put in different values for n, it's going to tell me how much that amount would be worth after n number of months of interest. So what you see here, a sub 1 is going to be 300 times that decimal raised to the first power. This is what's going to be what the last month, what we put in there, what that is going to end up giving us in value here. This one right here is if it sits in the account for 2 months, this is what it's going to give. If it has 25 months, it's going to be here. And for the $300 that we put in there that stays in there for the entire 5 years, 60 months, that is going to be this portion right here. So the account value after 5 years is S sub 60, and what's happening, we're taking each one of these. So this is the part that's in there for 1 month, then for 2 months, and so forth, all the way up, we're adding to it the part that's in there for 60 months. And so what happens on here, we look at this is a geometric series, so we can go put this into the calculator, and that will give us about 301.25, so that's our first term, times, r in this case is this decimal, times the quantity of 1 minus r to the 60th power, all over 1 minus r. And when I put that into the calculator, it comes out to be about $20,486.85, or really we could sit there and say $20,487. So that's one aspect of an application problem that you have, and there's other ones that you'll look at too, but you have to remember if you're looking for the nth term or you're looking for a sum. So with that, this does conclude the video that I have for geometric series, sequences and series. Again, as always, make sure to note any questions that you have as we went through this, especially on a story problem like this, and ask those in class. And with that, I will close, and I will see you in our next class.